You're standing on a beach, and the sand under your feet is hot enough to hurt. The ocean in front of you isn't blue cold, it's warm like bathwater left in the sun too long. Because it is. Behind you, there's nothing. No forest, no grassland, no green of any kind for 1,000 miles. Just red-brown desert, cracked and endless, running all the way to a horizon that shimmers with heat. This is the whole world, not a region, not a continent. The entire planet is basically one giant, merciless furnace of sand, and it has been this way for longer than you can imagine. Then, one afternoon, a cloud shows up. Just one. Nobody pays it any attention, because clouds here are rare and shy and they never amount to much. This one is different. It doesn't leave. More clouds gather behind it. And then, for the first time in longer than any living creature can remember, it rains. It will keep raining, on and off, for the next 2 million years. Welcome to the Carnian Pluvial episode. The strangest, wettest, most world-altering weather event in the entire history of our planet, and one of the least talked about disasters in Earth's story. This happened around 234 million years ago, deep in the Triassic period, long before anything you'd recognize walked the Earth. And I need to be upfront with you, there were no humans watching this rainfall. Not yet. Not for another 230 million years. But stick with me, because everything about the world you live in, the air you breathe, the soil under your feet, the very fact that mammals like us exist at all instead of a planet run entirely by reptiles, traces back to this one impossibly long storm. This is the story of how the modern world was basically born in the rain, and how the creatures that lived through it had to be rebuilt from scratch to survive what came next. So here's the big question. How do you survive 2 million years of near-constant rain when your entire species evolved for a bone-dry desert planet and has absolutely no idea what a rainforest even is? And here's the promise I'll make you. The answer isn't one single thing. It's not, they grew gills, or they moved to higher ground. It's a slow, brutal, multi-stage collapse, and rebuild that reshaped which animals got to rule the Earth and set the stage, quite literally, for the rise of the dinosaurs. Buckle up, because by the end of this, you'll never look at a rainy day the same way again. Let's start with how bad things actually were before the rain, because you need to feel just how insane this flip really was. 234 million years ago, all of Earth's land was smashed together into one supercontinent called Pangaea, one single gigantic landmass stretching from pole to pole. And because Pangaea was so enormous, its interior was almost completely cut off from ocean moisture. Picture the middle of the largest desert you've ever seen, then multiply that desert until it swallows nearly every scrap of land on the planet. Mountain ranges around the coastlines blocked what little rain did form from ever reaching the interior. Only the beaches and shallow coastal strips got any real water at all. And it wasn't just dry, it was hot. We're talking roughly 10 degrees CC warmer across the globe than today, and the seas themselves were sitting at around 47 degrees CC. That's not warm bath territory. That's you could not survive touching it territory. Life clung on anyway. Ancient insects scuttled across the sand. Early reptiles, tough and scaly and built for exactly this kind of punishment, ruled almost everything. And in the corners, in the margins, small and unimpressive and easy to overlook, were the earliest dinosaurs. Awkward, small, barely surviving new arrivals, nobody expected to matter. Out in the world's single vast ocean, Panthalassa, ammonoids and gastropods and sponges and corals, lived their entire existence never once worrying about rain, because rain on this planet basically didn't happen. So when I ask how did anything survive the rain, understand that this isn't a story about creatures adapting to a bit of extra weather. This is a story about an entire biosphere that had spent millions of years perfecting how to survive drought, suddenly getting drowned. Not for a season, not for a decade, but for 2 million years straight. So how does a world built entirely around scarcity not simply collapse the moment it gets exactly what it never had? The first answer is almost embarrassingly simple, and it starts underground, with a trigger nobody at the time could have possibly seen coming: volcanoes. Specifically, a colossal, sustained series of eruptions coming from what's now called the Pangaea terrain, a chunk of ancient volcanic rock that today sits along the coast of Alaska and British Columbia. These weren't ordinary eruptions. They were massive, repeated, and long-lasting, and they pumped staggering amounts of carbon dioxide straight into the atmosphere over an extended period. One geoscientist who spent years studying this, Jacopo Dal Corso, described the process almost like charging a battery: cooling high in the atmosphere on one side, and massive evaporation and heating down at the surface on the other. Charge that battery long enough, in exactly the wrong way, and eventually you don't get a storm. You get an engine that manufactures storms continuously for 2 million years. Here's the mechanism in plain terms. All that extra CO2 trapped heat. Trapped heat meant more evaporation off those already scorching seas. More evaporation meant more water vapor sitting in the atmosphere, waiting for somewhere to go. And once you push a hot, humid, moisture-loaded atmosphere hard enough, it stops behaving like a desert climate and starts behaving like a monsoon machine. The rain wasn't one continuous downpour, by the way. It came in intervals, waves of intense wet periods interrupting the old dry baseline over and over for 2 million years. Imagine your worst rainy season, and then imagine it as a permanent, recurring feature of your existence for longer than your entire species has walked the planet. The second piece of the story is what this rain actually did to the ocean, and it's here that the real culling began. All that extra CO2 didn't just heat the air, it acidified the seas. Pangaea, that single vast ocean that had been running quietly for millions of years, suddenly had its chemistry pulled out from under it. And the creatures that had spent eons perfecting shells and skeletons built from calcium carbonate, the ammonoids, certain reef builders, whole categories of marine life, found themselves living in water that was actively working against the one thing keeping them alive. Roughly a third of all marine animal species didn't make it through this, not because a wave crushed them or a predator hunted them to extinction, but because the ocean itself had quietly become hostile to their basic biology. That's a brutal kind of extinction. The world doesn't attack you, it just stops letting your body work the way it always has. On land, the third layer of this crisis was happening in the rock itself, and this is honestly one of my favorite parts of the story, because for a long time, nobody believed it was real. Back in the 1970s, two geologists named Schläger and Schonberger were examining rock layers in the northern limestone Alps in Austria, expecting the usual, consistent, unbroken layers of carbonate rock, the kind that forms in stable, arid conditions. Instead, they found something bizarre. A sudden band of dark gray siliciclastic rock jammed right in the middle of that otherwise steady record, dated to right around 234 million years ago. That kind of rock doesn't form in deserts. It forms in wet, rain-heavy, water-saturated environments. It was, essentially, a fossilized weather report, a single dark stripe in the stone saying, unmistakably, it rained here, and it rained a lot. For a long time, that was treated as a curiosity, maybe a local anomaly. Then the same telltale stripe started turning up everywhere. Southwest England, buried in layers of red sandstone, Israel, Italy, Utah, in the United States. The same story, the same dark band, written into rock formations on opposite sides of the planet. Alongside it, other signs of the deluge piled up. Deposits of amber, coal seams, ancient riverbeds and lake beds packed with fossilized plant debris, and a soft white clay called kaolinite that only forms under heavy, sustained rainfall. Even fossilized pollen and spores from this window in time told the same story. Hot, humid, saturated conditions, completely unlike anything that came before or after. This wasn't guesswork built on assumption. It was independent physical evidence, stacking up from continent after continent, all pointing at the same 2 million year anomaly. And yet, and this is the part that genuinely surprises people, this event barely gets mentioned. When scientists talk about Earth's biggest extinction events, they usually rattle off the same 5: Ordovician, Silurian, Devonian, Permian, Triassic, Jurassic, and Cretaceous, the one that got the dinosaurs. This one doesn't make the list, mostly because of when it happened. It didn't sit neatly at the beginning or end of a geological era the way the Big Five do. It happened in the middle of the Carnian stage, at what looks like a completely random point in time, and for decades that randomness made it easy for researchers to write off as noise instead of signal. Which raises the obvious question, was it actually random? Or did we just not understand yet what was steering it? So how did anything survive being simultaneously acid-bathed in the ocean and drowned on land for 2 million uninterrupted years? Here's where the story stops being about destruction and starts being about who got to inherit what was left. The next chapter is almost too strange to believe. This catastrophe was also a construction project. All that acid, all that rain, all that erosion. It was rebuilding the planet's basic chemistry in real time. The accelerated water cycle tore into the old landscape, causing rampant erosion and weathering on a scale the Triassic world had never experienced. The soil itself transformed, shifting from the pale, carbonate-based ground that had defined Pangaea's deserts into something much darker, richer, and more fertile. Dry, thin air gave way to genuine humidity. In other words, the rain wasn't just falling on the old world. It was actively dismantling it and laying down the raw materials for a completely different one. Then came the layer that changed who got to dominate this new world. Plant life flipped almost entirely. Ground-level vegetation, the low, scrubby stuff that reptiles had built their entire feeding strategy around, started losing ground to towering conifers and other large, tall-growing plants that thrived in the new humidity. If you were a reptile built to graze low to the ground, your food supply was quite literally growing up and out of your reach. If you were one of those small, awkward, previously irrelevant dinosaurs, though many of which were already built with body plans suited to reaching higher vegetation, this shift was the opening you'd been waiting for without even knowing it. Reptile populations that had ruled the pre-rain world began to decline. Meanwhile, the ancestors of animals we'd recognize today, early turtles, early crocodile relatives, emerged into this transformed landscape alongside the dinosaurs, finding their own footing in a world that no longer belonged to anyone in particular. Here's where it gets genuinely remarkable. In the ocean, the same chaos that killed a third of marine species also opened the door for entirely new forms of life. The newly acidic seas, oddly, ended up favoring the growth of plankton and coral reefs, kickstarting biological systems that hadn't existed at scale before. It's a strange, almost unfair rule of extinction events. They don't just remove life, they clear space, and something always moves in to fill it. The old marine order, built around organisms that had spent millions of years perfecting themselves for a stable, dry world ocean, got wiped hard enough that a newer, different marine order had room to take over. But the real turning point, the one you can't see in a single rock layer or a single fossil, the one that actually explains why we live in the world we live in, is timing. Because the disappearance of ground vegetation, the decline of the old reptile-dominated ecosystems, and the explosive diversification of dinosaurs did not happen as three separate coincidences. They happened together, in the same narrow window, as direct cause and effect. Researchers studying this period have been blunt about it. In the wake of widespread extinctions among plants and the herbivores that depended on them, dinosaurs were the main beneficiaries of the recovery that followed, rapidly expanding in diversity, ecological reach, and geographic spread, starting in what's now South America and eventually spreading to every continent on Earth. The rain didn't just fail to kill the dinosaurs. It cleared out their competition and handed them the planet. And there's a piece of physical evidence for this that gives me chills every time I think about it. In the Italian Dolomites, geologists have found rock layers where, beneath the reddish mudstone associated with this rainy period, there are no dinosaur footprints at all. None. And then, in the layers directly above, right as the rain event tapers off, dinosaur tracks are suddenly everywhere. Not a gradual increase, a hard line in the stone. Below it, a world without dinosaurs in charge. Above it, a world that already belongs to them. That's the reversal, sitting right there in solid rock, time-stamped by geology itself. The line between the old world and the age of dinosaurs isn't a metaphor here. You can put your hand on it. Of course, none of this happened smoothly or was accepted easily. When two British geologists, Michael Sims and Alistair Ruffle, first pieced this hypothesis together back in 1989, connecting Ruffle's work on strange rock layers in England's Mercia mudstone with Sims's research into a mysterious extinction event among crinoids. The response from the scientific community was not exactly enthusiastic. One of them later admitted that some fairly senior academics thought the whole idea was, frankly, ridiculous. A 2-million-year rain event reshaping the planet's ecosystems. It sounded like something out of a myth, not a peer-reviewed journal. It took years of additional evidence. The matching rock layers turning up independently across multiple continents, further research through the 1990s and 2000s, and eventually a full-blown international workshop dedicated to the topic in Italy in 2008, before the idea stopped being a fringe theory and became one of the more quietly important discoveries in paleoclimatology. There's something almost poetic about that. The story of the 2-million-year rain had to survive its own decades-long drought of scientific acceptance before anyone took it seriously. So let's get to the reversal, the moment where everything flips. For millions of years, this planet had been shaped entirely around scarcity, around drought, heat, and reptiles built to dominate exactly those conditions. Then the rain came, and it didn't just add water to that world. It systematically dismantled the rules that world ran on. It poisoned the old ocean chemistry. It buried the old carbonate soils under fertile new sediment. It starved the ground feeders and fed the tree reachers. And when the rain finally slowed, roughly 2 million years after it began, the planet that emerged on the other side wasn't a wetter version of the old Pangaea. It was, in almost every meaningful sense, a different planet. One where the awkward, overlooked, small-bodied dinosaurs that had spent their entire existence as background characters were suddenly standing at the front of the stage with nothing left in their way. Because here's the thing about the rain stopping. It did stop eventually, but the world it left behind never went back to what it had been. Pangaea did return to being mostly desert once the rains eased, but it was a different-looking desert, sitting on different soil, breathing different air. And this new equilibrium didn't last as a static thing either. As the late Triassic gave way to the Jurassic, Pangaea itself began tearing apart, splitting into the beginnings of new oceans and new continents. That breakup pumped even more humidity into the atmosphere, nudging huge portions of the planet toward a subtropical climate. Deserts that had defined the world for tens of millions of years started turning, in places, into tropical forest. The rain regulated itself too, settling into something closer to what we'd recognize today, 1 to 3 meters of rainfall a year, arriving in steady seasonal patterns instead of 2 million-year monsoons. And that, more than anything, is the sobering close to this story. The modern world you're living in right now, its climate rhythms, its familiar wet and dry seasons, the basic ecological rulebook that eventually allowed mammals, and much later, us, to exist, traces its origin back to this one catastrophic, barely remembered stretch of rain. Every mass extinction event gets remembered as a moment of pure loss. This one was that too. A third of marine life gone, entire reptile lineages pushed toward irrelevance, an ocean poisoned by its own atmosphere. But it was also, unmistakably, a construction event. It took a planet built for scarcity and forced it, drop by relentless drop, into becoming a planet built for something else entirely. For forests, for diversity, for dinosaurs, and eventually, hundreds of millions of years down the line, for us. There were no humans standing on that beach when the first cloud showed up and refused to leave. But every one of us is, in a very real sense, something that rain built. It didn't fall on our ancestors. It fell so that our ancestors could eventually exist at all. And then it kept falling, patiently, for 2 million years, until an entire planet had no choice but to become something new.